In figures 8.10 through 8.14, we're going to be looking at the various ways in which const can be applied to pointer variables and how that affects your ability to manipulate the data that a given pointer points to. Now we're going to start with figure 8.10, which is converting a string to uppercase using a non-constant pointer to non-constant data. This particular example is also going to start to show us some of the relationship between pointers and arrays, because we'll be working with a C-style string that's stored in a character array for the purpose of this example. Now you'll also notice at line 8 that we're including the header file cctype, which is the old C standard library ctype.h header file. Converted to its C++ name. And from that header, we'll be using the C standard library functions that are part of the C++ standard library called isLower and toUpper. IsLower determines if a given character is a lowercase letter, and toUpper converts a given character to its uppercase version. Now, for the purpose of this example, we have a function called convert to uppercase that receives as its argument a character pointer. Now, in the vast majority of cases, when you encounter a function that receives a char star as its argument, that means it expects to receive a C-style string, meaning a character array that stores characters and ends with a terminating null character to indicate the end of the C-style string. And that's what we have in main here, a character array called phrase, which is initialized with the phrase characters and $32.98. And basically we want to show you that when we run this program, only the lowercase characters get modified. And in fact, let's go ahead and run the program right now so that you can see that the original string had lowercase letters in it and the modified string has uppercase letters in it. So let's see how we're implementing that, talking more about pointers here and also about the fact that we don't use the keyword const with these pointers. In subsequent examples, we'll also take a look at using const as well. So we have this character array phrase. We output the initial value of that character array, and when you output a character array using cout, it assumes that you have a C-style string with a terminating null character stored in that array. So you just specify the name of the character array and it outputs it as a character string. We then pass the name of the array into the function convert to uppercase. Now here is our first introduction to the relationship between pointers and arrays. The name of an array is actually a pointer to the first element in that array. So the name phrase is actually a pointer to the character C in the array phrase. And because of that, when we're passing an array to a function, we don't need to take its address to determine where it starts in memory. It is already a pointer to the first element of the array. Now, because of that, the name phrase is really a pointer to a character. So we are able to take the location of the first character in the array phrase and assign that memory location to the parameter sptr that's being received in the function convert to uppercase. Now, we have a little while loop in the body of our convert to uppercase function, and what we're going to do is dereference the variable sptr and check if the value of that particular character is not equal to the null character, which indicates the end of a C-style string. If the current character is not equal to the null character, we're then going to check to see if that character is a lowercase letter by passing in the dereference pointer to the function isLower. IsLower will return true or false. True if it's a lowercase letter, false if it's not. If it is a lowercase letter, then line 30 is going to manipulate that particular character in the array, saying take that character, pass it to toUpper, which gives us back the uppercase version of the character, and then store that back into that particular character in memory. So if it's a lowercase c, it's going to be converted to an uppercase c, for example. Now, the next interesting thing that we do here is we apply the plus plus operator to the pointer sptr. And when you apply the plus plus operator to a pointer that points to an array of values, what that says is move to the next element of the array. So sptr++, when sptr first points to C, in characters and 3298 is now going to move SPTR to point to H. And now I can check to see if H is not equal to the null character and do my processing. Then I'll increment SPTR again, and it'll point to the A in the string, and then it'll point to the R and the A and the C, etc., moving one element at a time through the character array. And what you'll see later on in several other examples that when we apply the plus plus operator, for example, to an integer array, it's going to move one integer element at a time through the array. Not one byte of memory at a time, but one element's size at a time. So let's go ahead and run this program in the debugger so that you can see what happens. I'll put a breakpoint inside my convert to uppercase function in this case, and we'll run in the debugger. And let's just scroll down a little bit. So here we can see that SPTR has a memory address, and the dereferenced value of PTR is the character C. So if I step over this, and I'm just going to step over to the point where we're going to increment SPTR, and when I do that, you can see that now SPTR is pointing to the value H, which is the second letter in the string that we reference. And if I step a couple more times, we can now increment SPTR once again, and we can look at the value it's pointing to, and it's now the value A. And again, if we look at our original string, characters and 3298, initially it was pointed to C, then to H, now to A. And if I keep moving along, in fact, let's just step over this rapidly so that I get to the point where we're referencing the null character, so you can see the end of the whole process here. We're in the word and now we're working our way through 3298.98. Okay, so we're now pointing to the character 8 in our original string, which is the last character before the null character. And now, when I step, you can see that SPTR is pointing to the value 0, which is the character representation of the null character in memory. And because of that, when I now reach the top of the loop again, the condition is going to be false, indicating that we're now at the end of the string and we need to get out of this loop. So when I step again, I'm at the end of the function and I return back to main in this case. So this is just a demonstration of walking our way through a character array, one character at a time, manipulating the individual characters until we reach the terminating null character. In the next video, we'll continue our discussion of pointers and the use of the const keyword. Here, the key thing was that we were able to modify the pointer by adding 1 to it each time. That's because the pointer itself was not constant. It was allowed to be moved through memory, and we were allowed to modify whatever the pointer was pointing to because that data was not considered to be const. In the next example, we'll start to apply the const keyword to pointer declarations.